Good morning. We're going over application of quotient rules this morning. So average cost, average revenue, and average profit. I went ahead and just posted the completed notes on Canvas first because when I first recorded this, it just never, the recorder crashed on me. So I'm going to try to do this one more time. So I hope you are watching this. That means everything went as it's supposed to. But the second part is a little bit difficult, but then the first part isn't really that bad. So let's get started. I may just leave the interpretation already so that I don't have to rewrite that sentence. All right, let's get started. So we're looking at application of quotient rules. We have three quotient functions. To find the average cost, just like how you're finding the average grade. Like you take 5 tests and you want to find the average of those 5 tests. You add them all up, you find the total, and you divide by however many tests you took. Same thing, we're finding the average cost, so we're going to divide the total cost C of X by X items. So it's going to be a quotient. So you have to divide the cost function by the number of items that we are producing, and that will be the cost function. Okay, next one, if you want to find the average revenue, then you want to divide the total revenue, R of X, by the number of items that we sold. So R of X divided by X. These three functions, they all look the same, don't they? So if you're wondering about profit function, average profit, then you're going to divide the profit by X, the number of items that we are selling. So these are the three functions. These are, oh, I don't like how I use the same color twice. Even on Saturday morning, I'm being particular about these colors. Okay. So we got three quotient functions. Let's go ahead and use them first. An example is 6, part A. We're not really taking the quotient rule, using the quotient rule to take the derivative yet. We're just going to use those 3 highlighted quotient functions to evaluate the average cost, average revenue, and average profit. I know this because I went over this word already, but here's my recording. Paul's greenhouse finds that the cost in dollars of growing X 100 geraniums. Now I'm going to highlight this information because this could be tricky. So if Paul's greenhouse is producing X equals, not X equals, what if they are making 1,200 geraniums? Then we are going to say X is equal to 12, okay? Because we're doing X 100 geraniums, okay? I'm looking ahead. They said they're going to ask us to use 300 geraniums. So X is not equal to 300. X stands for how many hundreds of geraniums we have. So instead of X being 300, X is equal to 3. Just a little thing that could make a big difference when we find the answer. All right, but anyways, they're giving us the first function is the cost function. So the cost function says C of X is equal to 200 plus 100 times 4th root of X. What I know is that when I will take the derivative of the cost function, if I ever have to later, I will make sure to rewrite that 4th root of X. Whenever you have that 4th root of X, you can write that as X to the 1/4 power, right? But not right now. When they ask me to find the derivative of a cost function, maybe, but not right now. Okay, marginal cost, but not right now, I'm sorry. If the revenue from the sale of X 100 geranium is sold by, could be modeled by R of X. So they gave you 2 functions. They gave us the cost function and they gave us the revenue function. But where's the profit function? Nobody gave that to us just yet. So let us go ahead and find it ourselves. So profit function, or you can say profit. All right, hold on. P of X is equal to revenue minus the cost. If they're doing a good job, this profit will come out to be positive. If the business is not so hot, this profit will come out to be negative. Let us see how Paul's greenhouse is doing today. But let me go ahead and subtract to find the function. R of X is 120 plus 90 times the square root of X. And I'm going to subtract the cost function. And because the cost function is a binomial, I put it as in a parenthesis, okay? I wish I have room. What can I do, guys? I may be able to just bring this over to the top and then do it here. Okay, and I will simplify the like terms here, okay? 120 plus 90 times square root of x. I'm distributing this negative sign to get it out. It will be minus 200 minus 100 fourth root of x. I just need one more line, seriously. How about I bring this up? Okay, I'll do it here. What is that? That was for the geranium. Okay, and then I'm going to simplify by combining some like terms, which is 220 minus 200. That's going to give me negative 80 plus 90 square root of x minus 100 fourth root of x. There's no more like term, so I found a Pohl's greenhouse's profit function. Let's see if that's going to be useful anytime soon. So I'm going to go down. I'll go ahead and mark this. This is profit function for Pohl's greenhouse. Okay, so we have C of x, R of x, and P of x. Maybe just want to note that profit function, and in case, in the future, if they don't give it to you, just remember profit is revenue minus cost, okay? All right, let's go down to part A. What do they want? They want us to find the average cost. I'll do that first, okay? So average cost is C of x divided by x. Well, if we're talking about 300 geraniums, x is equal to 3, right? X is equal to 3. So I will go ahead and find C of 3 first, and then I will divide it by 3. So that is going to be, looking at C's over here, 200 plus 100 times fourth root of 3, and I will divide that by 3. And at this point, I'm picking on my calculator. My camera's off today, Saturday morning. I don't want to show. But anyways, I am holding my calculator on my hand, and I am typing that right now. 100 times fourth root of 3, and oh, that's not it. Fourth root of. So if I'm being a little slow, please be under. Well, thank you for your understanding. So I divided, I'm about to just hit the dividing button too. So I got 331. I'll show you. I'll just take it one more step. The numerator came out to be 331.61 cents, and I'm going to divide that by 3. And that comes out to be $110.54. So this is their average cost if they are producing and selling 300 geraniums. Okay, let's go ahead and find something else. They wanted us to find the average revenue. Which is going to be R of x divided by x. So R of 3 divided by 3. So if I plug in 3 into the revenue function, the x gets replaced by 3, and I will divide that amount by 3. 120 plus 90 times square root of 3 is 275.88, and I will divide that by 3. Oh no, $91.96. You know why I said oh no? The cost is bigger than the revenue. So, okay, I can do the average profit using the profit function that we wrote. Absolutely. But it's going to be the same as we take the easier way. But I want to do it both ways, and I'll show you that they are the same thing. P of 3, according to our profit function, which is, I'll go ahead and write that down here. P of x is equal to negative 80 plus 90 times cube root of x, square root of x, minus 100 times fourth root of x. That's what we found out by subtracting earlier, right? So I'll go ahead and use that because we came up with it. And now we'll go ahead and divide by 3. We don't have to do it this way, but you know, why not? We found the profit function earlier. I'm typing that in. And the numerator came out to be negative 55.72. And I'm going to divide that by 3. And the answer will come out to be negative $18.57. And this should be the same answer that we will get if we subtract average revenue. Let me go ahead and write that down here. Average profit. We can find this by doing average revenue. Let us go ahead and abbreviate this to average rev and average cost, AVE cost, which will be $91 and I do want to draw this dollar sign. $91.96 minus $110.54. And if we do 91.96 minus 110.54, you do get the same amount. I was a cent off because of rounding, I guess, but oh, that's okay. That's okay. So I usually just subtract, but hopefully when you're doing these homework problems, if you see them on your, I think I got this example from your textbook, and I do want to check out how the textbook solve it. If they simply subtracted it or they found the profit function and actually used the average profit formula. But both ways are fine. Both ways are fine. Okay, now let's do the quotient rule. So the part A wasn't really about doing the derivative, but part B we have to find the derivative because, look at the wording, they want you to find the average profit at the rate at which the average profit is changing. We're talking about the average rate of change here. Okay, so this is how fast the profit's changing. So let me go ahead and write down this gray highlighted part in just function notation and what we are trying to find. So average profit, write down average profit first. Average profit is P of x divided by 3. I'm sorry, x, right? P of x divided by x. That's the average profit. But we want to find out how fast this is changing. So what we are doing is we're finding the derivative of this. We can use two different notations, but I am going to go ahead and use this. So we're finding the derivative of this average profit function with respect to x. Same thing that you can say is P of x divided by x of prime. So I'll find that, okay? So because you see this is a quotient, we are going to use a quotient rule. Okay. This is an application of a quotient rule problem. So alrighty, let's go ahead and find the quotient. I'll use the quotient rule. So first, I will replace this P of x over x with what it is. So the profit function was negative 80 plus 90 times square root of x minus 100 times fourth root of x. And all over, we're going to put our x there. X. You okay so far? Okay. And then I do not like the look of these guys. Look at these. I'm going to rewrite these two square root and fourth root notation so that I can apply the power rule when I'm finding the derivative. Negative 80 plus 90 times x to the 1/2 power, right? That's how you can rewrite the square root of x minus 100 times x to the what power? 1/4 power. So that is the first thing that I did. All over x. I am ready to apply the quotient rule, okay? So to do the quotient rule, I like to label my pieces. I call the first function on top of the fraction f. So f is negative 80 plus 90 times x to the 1/2 minus 100 times x to the 1/4. And I need to take the derivative of that. Derivative of -8 is 0. All right, let's do the derivative of the second term. I need to do 90 times half, which is going to be 45. And the new exponent will be 1 less than positive half, so that will be negative half. All right, and then I do half quarter times 100. 1/4 of 100 is 25. And the new exponent, I need to go down 1 from quarter. So what is 1/4 minus a whole 1? So I'm doing 1/4 minus 4/4. That gave me -3/4. So the new power is -3/4 by subtraction, okay? So I'm done with the numerator function. Let's look at the denominator, the bottom of the fraction, x. So, that's super easy. Derivative of x or 1x is simply 1. So these are my quotient rule pieces. Okay, and now I'm ready to plug in all these good pieces to do the quotient rule. I will go ahead and write the quotient rule here. Quotient rule goes like this. gf prime minus fg prime, and we will divide it by g squared. Okay, so the derivative of this is going to be, I will first put, you know how I like to do, I usually put the denominator first. The denominator is g, which is just x. So the bottom of the fraction, I will simply put x squared. On top of the fraction, let's move to the top of the fraction. What is g? Well, g is still x. So put the x, we'll put parentheses because now let us put f prime next to it. F prime is this binomial with some nasty looking powers. So let me go ahead and put those in the second parenthesis. 45 x to the 1/2 power. Whoopsies. See, it's -1/2 power. Minus 25 times x to the -3/4 power. I will close the parenthesis, and I will have to extend my fraction bar a little bit longer. The next sign is minus sign. Write the minus sign, and let's go ahead and grab our f. F is this long trinomial, so I will have to put that long trinomial in my parenthesis over here. Parenthesis, -80 plus 90 times x to the 1/2 minus 100 times x to the 1/4. I will close the parenthesis. I am almost done. Let's now go ahead and multiply this by g prime. Oh, thank you. G prime is simply 1. I was getting worried about distributing or foiling or multiplying that long trinomial by something. But if it's multiplying by 1, I am not worried anymore. So I want you to clearly see these quotient rule pieces that I put together. And I would like to use these colors to help you. I hope you guys can see colors. Okay, so that's it. I did the quotient rule, and then my job is to simplify the numerator. Now watch very carefully. I am about to do the exponent property here. This is x to the first power, right? X to the first power, because the next step is for me to distribute this x to the first power to these two binomials, to these terms inside. So when you multiply powers, for example, if you do x to the first power times x to the -1/2 power, you must add the exponents. You have to do 1 plus -1/2. You're adding the exponents, so which turns into x minus half. That's why the first term, I will write it as 45 x to the +1/2 because I combined 1 and -1/2. Minus, I will delete this, I will erase this work, okay? The next power is going to be x to the first power times x to the -3/4 power. So I need to add those fractions. X to the first power times x to the -3/4 power. You have to add these powers. So x to the 1 plus -3/4 which becomes x to the 1 minus 3 over 4. That's why I will have x to the positive 1/4 minus 25 x to the positive 1/4. I am done with the first one and the second one. Hold on, let me erase some work. Distributing 1 doesn't change anything, right? I was going to do this. Distribute 1, distribute 1, distribute 1. That's silly. Distributing 1 doesn't change anything. So how about we distribute this the negative sign. Let's go ahead and distribute this negative sign so that we can get this trinomial out of this parenthesis. And good news is we don't have to worry about the powers because we're not distributing on x. So this will be plus 80 minus 90x to the 1/2 power. And then 100 is going to turn into positive. So I changed the sign of all the terms in the second parenthesis. Now, let's see if we can identify any like terms so that we can combine them, okay? If they have same power, they are like terms, right? I see there is 45x to the 1/2, and there is negative x to the negative 90x to the 1/2. Those two are like terms. If I combine them, I will get 45 minus 90 is negative 45. Guys, this is Saturday morning at 7:30, so I want to double check everything. I don't want to make a silly mistake. Negative 45x to the 1/2 power. I also notice there is another like term. I see there is negative negative 25x to the 1/4 power and positive 100x to the 1/4 power. And I box them with orange highlighter so that you can see them. If I combine them, 100 minus 25 will give me positive 75, and it will remain as x to the 1/4 power for the variable. I'll bring down my plus 80. And it is still all over x to the 1/2 power. So guess what? We just found the derivative of the profit function, didn't we? This is awesome. Now what do we do? We're going to go ahead and now plug in 3. Why? Because they want you to find the average rate, the rate at which the average profit is changing when they are selling or growing and selling 300 geraniums, and x stand for the number of hundreds of geraniums. So we're going to plug in x equals 3. Okay, ready? This is the fun part. Negative 45 times 3 to the 1/2 power, the same thing as square root of 3, plus 75 times 3 to the 1/4 power, plus 80, all over 3 squared. All right, I'm about to plug this into my calculator. And when I evaluated it, I got $11.90. Oh, it's awkward. It's 19.5. So I will go ahead and round it to 20. And this is how fast their profit is changing, how their average profit is changing. At the moment, they are growing and selling 300 geraniums. So I need to make it as the unit has to be a right. So $11.20 per, and their unit was 100 geraniums, right? Per 100 geraniums. So at least their average profit was negative, but it is growing. It's a positive number. So hopefully this matches what I got 2 days ago when I did this and the recording failed on me. So let me read the interpretation of this, and then we will stop this lesson. When 300 geraniums have been grown and sold, the average profit is increasing. So that is a good news for Paul's greenhouse. At least it's increasing. Why? Because it came out to be a positive number. It's increasing by $11.20 per 100 geranium for each additional 100 geranium sold. Okay, so I hope this made sense, and please keep on doing what you're doing. Watch these videos, and if you feel like, because sometimes I will get lazy, or if my computer crashes and I don't want to record it the second time, I just kind of put the notes on and see if you notice. You guys are doing an awesome job because you're emailing me about missing videos, and if you let me know, I will of course go back and do this again, just like today. But I hope this was helpful, because for me, listening to someone talking about it helps so much more than just looking at what's been written down on the note. So that's it. I hope I will see you next week for our class meeting then. Bye bye.